All right, welcome everyone to another deep dive. We're all here today to explore a topic that I'm sure you'll agree is pretty crucial in the world of industrial automation and manufacturing, machine safety systems.
Absolutely. And we've got a great resource to draw from today with this material from PowerSafe Automation.
Yeah, it looks like they put together a really comprehensive overview, covering everything from basic machine guarding those physical barriers you see in factories to the more advanced electronic safety systems.
Right. We're talking about presence sensing, protecting those moving parts, and even diving into the control systems that really tie everything together from a functional safety perspective.
So our mission today, if you will, is to kind of unpack all of this, to distill the key principles and takeaways behind these different safety strategies.
Yeah, to give everyone listening a solid understanding of how each approach works and why it's so important for keeping operators safe in industrial environments.
Okay, so let's jump right in with something that I think everyone can picture. Machine guarding. When we talk about machine guarding, what are we really talking about?
Well, at its core, machine guarding is really all about creating that physical barrier between the operator and the hazardous parts of a machine.
Yeah, that makes sense. Kind of like a fence or a wall.
Exactly. You're trying to prevent any accidental contact, especially during a production run when the machine is operating.
So this is during normal operation, but what about when the machine needs to be set up or adjusted or repaired? I imagine there are times when someone needs to interact with those hazardous areas.
Right, and that's an important point. You can't just have a completely sealed off machine in most cases.
Mhm.
There will be times when access is required, and that's where additional safety measures come into play.
Okay, so back to the physical barriers. What are these guards typically made of? I'm picturing some heavy-duty materials.
Oh, yeah. You'll often see frameworks made from robust stuff like T-slot aluminum or steel. These frameworks then hold panels that can be made from various materials. Wire mesh is pretty common, as is polycarbonate for its strength and transparency.
I see. So it's not just about stopping someone from reaching in,
Hmm.
but also maybe providing some visibility into what's happening inside.
Exactly. And what's even more interesting is that these guards often have safety interlock systems built right into them.
Interlock, so it's not just a passive barrier. There's some intelligence built in.
Right. Think of it like this. If you try to open a guard while the machine is running, the interlock system detects that and immediately stops the machine.
Ah, that's smart. So it's like a built-in fail-safe to prevent someone from accidentally reaching into a danger zone.
Absolutely. And this isn't just a nice-to-have feature, it's a fundamental safety principle that's driven by regulations and best practices. OSHA, for example, has specific requirements for machine guarding under Section 1910.212A1.
And I think you mentioned ANSI B11.1 here as well, right?
Yeah.
Another set of standards that guides the design and implementation of these interlock systems.
Yeah, you've got it. It all comes down to making sure these interlocks function reliably and consistently to prevent accidents.
That's really interesting. Now, I noticed that PowerSafe Automation specifically mentions custom-designed legacy machine safety guards. What's the significance of that legacy part?
Well, when we talk about legacy machines, we're often referring to older equipment that might predate some of the more modern safety standards.
Oh, so they might not have been designed with these built-in interlock systems or the same level of guarding as newer machines.
Exactly. So PowerSafe Automation specializes in creating custom guards that can be retrofitted onto these existing machines to bring them up to current safety standards.
That's got to be a pretty tricky engineering challenge, right? Trying to integrate modern safety features onto older equipment that wasn't necessarily designed for it.
Oh, absolutely. It requires a lot of expertise and careful planning to make sure the guard is effective and doesn't interfere with the machine's operation.
It's like trying to put a square peg in a round hole, but with really high stakes.
Yeah, that's a good analogy. And what's really crucial here is that balance between safety and productivity.
Because you can't just shut down a factory or completely redesign a machine every time safety standards evolve.
Right. You have to find ways to implement these safety measures in a way that's practical and doesn't disrupt operations too much.
That makes a lot of sense. So it sounds like there's a whole art and science to retrofitting these legacy machines with appropriate guarding.
There really is. It's about finding that sweet spot where safety and production can coexist.
Okay, so we've talked about physical barriers, but now let's move on to something a bit more high-tech. Presence sensing safety. What exactly does that involve?
Present sensing safety is fascinating, really. Think of it like an electronic guardian, constantly watching for any intrusion into a dangerous area.
Okay, so instead of a physical barrier, we're using technology to detect when someone's getting too close.
Exactly. These systems are all about using sensors to detect the presence of a person, or even just a part of their body within a defined safety zone.
So if I were to accidentally reach into a hazardous area, these sensors would pick that up and trigger a safety response.
That's the idea. They act as an extra layer of protection, especially in situations where physical guards might not be practical or sufficient.
I see. So what kind of technology are we talking about here? What are these sensors actually using to detect someone's presence?
There are a few different types, each with its own strengths and applications.
Okay, tell me more. I'm intrigued.
Well, one common type is the safety light curtain. Imagine a curtain of invisible light beams that creates a safety zone.
If you break the beam, the machine stops.
Right, exactly. It's like tripping an invisible alarm.
That's pretty cool.
Yeah.
What about larger areas? Do they have sensors for that too?
Absolutely. That's where safety laser scanners come in. They can monitor a much wider and more flexible area.
Wow, so they can detect someone approaching from any angle.
Pretty much. And then you've got safety mats, which are pressure sensitive.
So if someone steps on the mat, it triggers a safety response?
You got it. They're often used in front of machinery or in areas where you want to prevent access.
This is amazing. It's like having an invisible force field protecting people.
Yeah, it kind of is. And it's getting even more sophisticated with 3D safety radar smart sensors. These use radar technology to create a three-dimensional map of the protected area.
I can only imagine what the future holds for this kind of technology. It's incredible.
It really is. But here's the thing, the sensing technology is only one part of the equation.
Okay, so what's the other part?
It's about how that sensor information is processed and acted upon. That's where those redundancy checking monitoring devices come in.
I remember seeing that term in the material. What exactly are they?
They're the brains behind the safety system. Things like safety relays, safety controllers, and safety PLCs.
PLCs. That stands for programmable logic controllers, right? Those are like specialized industrial computers.
Exactly. And in this context, a safety PLC is specifically designed to handle those critical safety functions.
So it's taking the input from the sensors and deciding what action to take.
Precisely. And it's constantly checking itself for any faults or errors to ensure that the safety system is functioning correctly.
This sounds incredibly important. I mean, you're relying on this system to keep people safe.
Absolutely, which is why there are very strict standards and regulations governing the design and implementation of these safety systems.
Like what, for example?
Well, one key standard is EN 138491. This is a globally recognized standard that sets specific requirements for the reliability and performance of safety-related control systems.
So it's a way to ensure that these systems are designed to be extremely dependable and fault-tolerant.
Exactly. And you'll also find national electrical codes that come into play, like NFPA 70 here in the US.
Okay, that makes sense. Electricity and safety are definitely two things you don't want to mess around with.
No kidding. These codes help ensure that everything is wired correctly and that the electrical systems themselves don't pose a hazard.
Right, so we've covered physical guards and electronic sensing systems. Now let's move on to another critical aspect of machine safety. Protecting those moving parts, those power transmission systems.
This is a big one. Anytime you have moving parts in a machine, you have the potential for serious injury.
I can imagine. Things like rotating shafts and gears and belts.
Yeah, exactly. You've got rotating shafts that transmit power from a motor, chain drives that move things along, gears and sprockets that mesh together to change speed or direction.
And belts that drive various mechanisms, right?
Right. And you can't forget about the components and conveyor systems like the idler rollers and drive belts.
I'm sure you get a picture of just how many moving parts there are in a typical factory.
It's a lot, and OSHA has very specific regulations about guarding these systems. Section 1917.151 lays it all out.
Okay, so OSHA is really on top of this. What kinds of hazards are we specifically trying to prevent with these guards?
Well, you've got the classic pinch points, where a body part can get caught between two moving objects.
Ouch, I can see how that could be bad.
Yeah, and then there are cut points, often involving sharp edges or fast-moving components.
So it's not just about being crushed, it's about being cut as well.
Right, and then you have wrap points, where clothing or even limbs can get entangled in rotating machinery.
That sounds terrifying. Like getting sucked into a giant blender.
It can be incredibly dangerous. And finally, you've got shear points, where parts move past each other with a scissor-like action.
So you could basically get sliced.
Pretty much. That's why guarding these power transmission systems is so critical.
It makes sense. So what kinds of guards are typically used?
It can range from simple covers and shields to more elaborate enclosures.
I guess it depends on the complexity of the system and the specific hazards.
Exactly. But what's really interesting is the increasing focus on user-friendly design.
What do you mean by that?
Well, for example, you might have guards with integrated safety switches. So when you open the guard, it automatically shuts down the machine.
Ah, so you don't need a separate safety mechanism. It's built right into the guard itself.
Right. And then you have features like anti-restart protection, which prevents the machine from starting up unexpectedly if someone's still working on it.
That's important, especially in environments like machine shops or maintenance areas where you need quick access for adjustments or repairs.
Absolutely. And this user-friendliness is also important when you're dealing with experienced machinists who need some flexibility in their work.
You don't want safety measures to become an obstacle to productivity.
Exactly. It's about finding that balance between safety and efficiency.
Right. And this is relevant across a lot of industries, right? From general manufacturing to agriculture to mining.
Oh, yeah, you see it everywhere. And in some industries, like mining, you might even have specific safety training requirements, like MSHA 24 training.
Okay, that makes sense. Different industries, different hazards, different training.
But the underlying principle is the same: to equip workers with the knowledge and skills they need to stay safe on the job.
So we've covered physical barriers, electronic sensing, and protecting those power transmission systems. Now let's get to the brains of the operation: functional safety control systems.
This is where things get a bit more technical, but it's all about ensuring that the control systems that actually operate the machinery are designed with safety as a top priority.
So it's not just about having safety devices bolted on. It's about baking safety into the very way the machine is controlled.
Exactly. It might involve upgrading older control systems that lack modern safety features or adding new infrastructure specifically to enhance safety performance.
And I bet those presence sensing devices we talked about earlier play a big role in these systems.
Oh, absolutely. They're often integrated into the control system to provide that real-time feedback about what's happening in the work zone.
So the control system is constantly getting information from the sensors and adjusting its behavior accordingly.
Exactly. It's all about creating a dynamic and responsive safety environment.
Fascinating. So what kinds of components are we talking about when we talk about functional safety control systems?
Well, there's a whole range of devices that can be used depending on the specific application.
Okay, give me some examples.
You might have two-hand controls, which require the operator to use both hands to initiate a hazardous operation, thus keeping their hands out of harm's way.
Smart. So you can't accidentally activate something with one hand while the other hand is in a danger zone.
Exactly. And then there are press safety devices specifically designed for mechanical presses, e-stop buttons that can immediately shut down the entire system in an emergency.
Those are pretty common, right? You see them on all kinds of machinery.
Oh, yeah, they're essential. And you might also encounter safety equipment for fluid power systems like hydraulics and pneumatics.
I'm not as familiar with those. What are they for?
Well, hydraulics and pneumatics use pressurized fluids or air to generate motion and force. So these safety devices are designed to prevent accidents related to those systems.
I see. So it's all about controlling the flow of energy and ensuring that it's directed safely.
Exactly. And then you have specialized equipment for hazardous locations, often called HAZLOC.
HAZLOC.
Yeah.
What kinds of places are we talking about?
Environments where there's a risk of explosion or fire due to flammable materials being present.
Oh, right. Like in certain chemical processing plants or refineries.
Exactly. And even non-safety devices can play a role in the overall safety functions.
How so?
Well, they might provide information or support functions that help the control system make better safety decisions.
I see. It's all about having a holistic approach to safety, where all the different components work together.
Absolutely. Now, one key concept in functional safety is control reliability.
Okay, I remember seeing that term. What does it mean exactly?
It refers to how consistently and reliably the safety control circuits can perform their intended function.
So it's not just about having safety features, it's about making sure they work reliably over time.
Right. And there are standards that define how these circuits need to be designed and tested, like CAT3, which stands for Category 3, and PLD, which is Performance Level D.
So those are like quality benchmarks to ensure that the safety circuits are up to snuff.
Exactly. They help ensure that the circuits are robust enough to handle the demands of a safety-critical application.
Because if a safety system fails, the consequences can be dire.
Absolutely. And that's why there's so much emphasis on verification and validation, making sure that the system has been thoroughly tested and proven to work as intended.
Right. It's like the rigorous testing that they do in the aerospace or automotive industries.
Exactly. And that testing often involves looking at things like electrical schematics and fluid power schematics.
Okay, why are those important?
Those schematics are basically detailed diagrams that show how all the components are interconnected and how they're supposed to function.
So they're like the blueprints for the safety control system.
Exactly. And having those accurate and up-to-date plans is crucial for maintaining and troubleshooting the system.
Makes sense. If you're going to make changes or upgrades, you need to know how everything is wired and how it's all supposed to work together.
Absolutely. Now, if someone's feeling a bit overwhelmed by all of this, a good first step is to conduct a comprehensive risk analysis.
Okay, that makes sense. Start by identifying the specific hazards and risks.
Exactly. Once you understand the risks, you can then start to evaluate which safety solutions are most appropriate for your particular situation.
It's like a doctor diagnosing a patient before prescribing a treatment.
I like that analogy. You need to understand the problem before you can find the right solution.
Well, I think we've covered a lot of ground today in our exploration of machine safety systems. We've looked at physical guarding, presence sensing, protecting those moving parts, and those all-important functional safety control systems.
And it's been a really fascinating deep dive into the world of industrial safety, thanks in large part to the information provided by PowerSafe Automation.
Yeah, they've given us a lot to think about. It's clear that each of these approaches plays a crucial role in keeping workers safe around machinery.
And it's all about finding the right combination of safety measures for your specific needs.
So as you, our listener, consider all of these different facets of machine safety, here's a question to ponder. What are the key factors you should consider when choosing the most effective safety solution for your workplace?
Yeah, think about the specific hazards, the types of machinery you're using, and the level of interaction required between operators and machines.
And remember, safety is an ongoing process. It's about constantly evaluating risks, implementing appropriate safeguards, and staying up to date on the latest technologies and best practices.
And don't be afraid to reach out to experts like PowerSafe Automation if you need guidance.
They're a great resource for anyone looking to improve machine safety in their workplace.
Absolutely. So thanks for joining us on this deep dive into machine safety. Stay safe out there.
Until next time.